The standard sump on the T150 Trident is held on with 6 studs. There is no provision to easily drain the oil, although some aftermarket sumps I've seen have a boss there with a drain plug in it, and I did think about welding on a boss here and then drilling through and making a drain plug, but my welding, I'm still learning obviously, and I thought that's a little bit difficult. There are sumps available online, aftermarket ones, billet ones, that actually have that facility built in. My plan is to make my own. To that end, I have some billet, 12mm thick billet, and I'm going to machine this so that it looks something like that. So, but to do these curved ends, there are some ways of doing it. You could actually use a fly cutter, such as this device, and by setting the diameter, you can actually cut each end, and that's a possibility, and I might do that. The other option is to use a rotary table, and a friend of mine gave me a rotary table, and I'll turn it around, and you can, by rotating this, turn the top around, and then I could use a fixed cutter and just sort of mill around the edge. To do that, you need to be able to bolt the material down onto the top, and to do that I have an interface plate that this will actually bolt onto, and I can drill the holes in it for the bolt downs, and then drill some holes into the faceplate and thread them so I can bolt down the thread pipe. And of course I can use probably 4 of the holes to hold this down, because the cutter is actually inside. One of the issues I found is that my regular T-nuts are way bigger than this. So a buddy of mine suggested I get some smaller T-nuts. You can get other sort of nuts of course, but a T-nut is ideal, that fits into there, and then I will use a countersunk screw that will actually bolt down and bolt down my faceplate. But the T-nuts that I bought are obviously the right width for that, and go in quite nicely, but you do have to machine them. The height for the actual T part is slightly too tall, by about 0.8 of a millimeter. So what I have been doing, and I have done that on 3, is to mill down the let me get rid of this, to mill down the T-nut and make it such that it fits. Now I have a 3/8 end mill that is wider by a little bit than the actual T-nuts, so that I get a completely flat surface on the T-nut to allow it all to fit. And I need 4, so I've done 3, so I'll just get the last one done. So having milled the flat bottom, I'm now going to fit that into the, I'm not sure if you can see that, into the T-slot very nicely. The interface plate is 10mm thick and the centre hole is at 0,0 set up on the DRO, and then the 2 longitudinal ones are at plus or minus 40 millimeters, and then the 2 crossways are at 25, I think, yes, 25 millimeters, and the final countersink. And we'll just check that, make sure it's down far enough. I'm going to put that there. Yep. Okay, so we now have a tie down plate to go onto the rotary table, so I can then put the 6 holes in and tap them for the sump. The plate bolts up to the rotary table, and of course I can now rotate it, and yep, it does clear. I was a bit concerned that it wouldn't. The interface plate for the machining the Triumph Trident Sump, I have drilled and tapped a 1/4 UNC thread that will actually hold the sump plate down, so I can actually drill the other 5 holes. So I've designated that hole 0,0, and I'm now going to move it around and set up so I can drill the hole the other side in the right place, using my transfer punches to find the centers. I have turned the interface plate around and mounted the sump onto the top of it, and I have put a 1/4 UNC countersunk screw in, and I'm using the countersink as a way to center the plate around the hole. So then what I'm going to do is take that out and then use a transfer punch to find the center of that hole again and set that on the DRO to 0,0, and then I can then measure the distance at this point, and probably these points as well, and then write down exactly where they are on my document. Having used the transfer punch, I have measured the position all of the holes with respect to that hole. So I can now take this apart, mount it up, ready to actually drill some more holes. I have repositioned the plate and the parallels so that I can actually drill all 5 holes in one go. And I have found the 0-0 position again and set that onto the DRO. I have decided to use a 5mm drill bit. It should be 5.1, but I think we can forgive that, as I already have the chuck set up, rather than go into a slot drill, which actually tends to move the whole unit very slightly. I do not have a tap-in head, and I still want to get the threads vertical, so I'm going to use the milling machine, not switched on, just to just to get the tap started. I put a light bit of pressure on the drive, and once it is actually started in there, once the tap is started and I know it's vertical, so here we are, tapping out the last hole. I've already been down this with a tapered tap, so just going with the finishing tap. Well, that's exciting. All the screws are in. I've used the countersunk screws because I haven't got any short ones of the standard Allen key type. I have them on order, but yeah, that works well. So I can now get on putting this onto the rotary table, the interface plate, and moving forward. I am bolting down, fixing the first sump plate. I'm making 2 initially, onto the mill, so that I can actually drill the 6 holes straight off. There's space for me to actually get to all of the holes position, and I've checked with the sump, and we need a 6.5mm clearance hole, because that's what's in the sump at the moment, so that's what we'll do. So we have the 6th and final hole, which we shall get on a drill now. I have remounted the plate, sump, that I'm going to machine out, and I'll actually drilled the clearance holes for the studs at 6.5mm, and it seemed a little tight going on to my crankcase, so I looked it up, and for a 1/4 inch stud, the clearance is at least 7mm, depending on how tight you want it. So I've drilled them out 7mm. So now we start the scary bit of trying to mill out the internal. I've set the cutter up for 33mm radius, and I've set the point at the centre of the circle, and now I just have to mill it down, so we'll see what happens. So, seems to work okay. Let me clean it off a bit and have a look. Yeah, so we've got to go down at the shallow end 1mm. The other end it will be deeper, and the bit in the middle, that's where the slope will be, so that will be milled out on the rotary table, as will the deep end, because I can't go deep enough with this cutter. Yeah, I can go down to about 3mm on this end, which will work, I think. So in my quest to make another T150 sump plate, but with a drain plug, I have a rotary table that a friend gave me on my small hobby milling machine. I have an interface plate that I machined and then realised I hadn't done it accurately enough, so I remade the interface plate basically with 2 hole downs and then the holes to hold the material, and I have bolted the unit on and checked to make sure that the mill cutter, which in this case is a 6mm cutter, slot drill, because this is a glorified slot effectively, will actually follow the curve that I want. I've worked out the center is the hole in the middle, and you can see that it's offset. The offset in the slide dictates the actual circumference of the circle, and then offsetting the interface plate, sliding it one way or the other, allows me to mill either one end or then slide it up, mill the other end. This is not actually symmetrical, so you can't actually just rotate it all the way round and have it line up, because it doesn't, unfortunately. You do need to be able to slide it that way to get to this end. I've tried taking it off, turning it round, and then trying to mill the other end, but it's out by just a couple of millimeters, which is not helpful. So I'm going to have to do this in stages, which I knew anyway. So I have a material that I've actually drilled the holes in. That's better. Swarf. Swarf's not your friend. With my type of cutter and 6082T6 aluminium, it says we want about 380 RPM. So that's a little high. So there's 0.1. see that managing that is going to be a bit of an issue. Yeah. So let's go the other way. Oh, that's interesting. Ah, moved. I'm not sure why that clamp keeps changing, or whether the chatter is going to be an issue, but we'll see how it looks. And then this is all very new to me, of course. I do know I need to come down here 39mm, so I think I'll do that next. To put in the prototype sump back onto the milling machine, I'm actually chopping off some of the excess material using my bandsaw rather than trying to mill it all off, which I could do, of course, but it would just take a reasonably long time. So I am putting a slope internally similar to this one, only much narrower, because I want to put the drain valve in the middle, and I don't want to compromise the depth of thread. So I have been milling around the edge of the prototype sump using the original sump as a guide, and I have one more cut to do. I've got a nice finish. I'm going to do some of the bits on the corners that I haven't been able to, well, I mean, I could try and use the rotary table, but that's quite a lot of setting up to get that right. So I'm just going to use a sander and bench sander, and I have the prototype sump on the interface plate, and I've been using the interface plate to support the sump while I actually milled out the cutouts for the studs, because the plate is much thicker than the studs allow. It's very similar to the original plate, except of course I haven't put any fins in yet. I might do that, and I haven't put the plug in that I have prepared. It's a quarter BSP plug, and it will have, well, it's got a magnet in the middle, except it's not quite in the middle. I have reset the sump, ready to actually make the threaded hole for the drain plug, which is going to go in the middle there, quarter BSP, and I'm going to recess it slightly, not quite as deep as these because the head isn't as deep, but deep enough, I think, such that it's relatively protected if something does get underneath the bike. I have the hole in the center is my 00 mark, that everything else is marked around, and it's a 6.5mm hole, and I use a reverse 6.5mm drill, in fact the one I drilled the hole with, to actually find the 0 point. And then I've locked everything down tight so that I can now drill the tapping hole, 11.5mm. It should be 11.8, but I don't have 11.8 drill. It's into aluminium, and then I'm going to tap it out with a quarter BSP tap. But before I do that, I'm going to use the same end mill that I used for cutting out the recesses to actually make a recess for the plug. So I have drilled through with the 11.5mm drill, and now what I'm going to do is to use an end mill, because I'm not cutting the center, and actually put a recess in. Haven't worked out quite how deep I need to go, so I'm going to do that first. It turns out the end mill is the same diameter as the hex on the top of the BSP nut, so I'm going to cut the thread first, and then I'm going to use a slot drill on the rotary table and just clear out an area that will actually give me room to get a socket in. To ensure I get the thread vertical in the plate, I'm going to start it off with the tap in the mill, although I'm just turning it by hand, and then once it's engaged and pulling itself in, I'm going to not in yet. So it is now drawing the tap and of course the quill of the milling machine down into the material. So what I'm now going to do is release the quill and then use a tap wrench with a guide into the end of the tap that fits up into the mill. With the tap started in the material, I now have a sprung-loaded plunger that I'm going to bring down into the center of the tap So, and I'm going to use a tap wrench. I'm wearing gloves, even though I do have caps on the end of the clamp bolts, because I really need to sit down and clean up all the ends of these. I keep getting cut. And we're all the way through. Just make sure. Good. As you can see, it's going to sit a little proud, so I do need to sink it down in. So I'm going to go and measure a socket and see just how big a recess I need, and I'm obviously going to do a little bit of a countersink on that so that it starts better, because that's a bit of a pain at the moment. But at least it goes in. I need to, well, don't need to, but I'm going to recess the sump plug into the body of the sump plate to make sure that the magnet is actually in the oil, and this is 4mm deep, so I can go down about 4mm, and I have a clearance around that a socket will actually fit in and allow me to undo the sump. And of course it will be protected by a certain extent by the amount of material either side of it in case something gets under the bike. So I've actually practiced this a little bit. Okay, so we are all locked down. Bring it down. I'm actually using a slot drill. I will be back when I've actually machined that out. So I have completed the rotation. All the way around. I'm at 4mm deep. Let's see what we've got. Looks to be about deep enough. It is 4mm. So let's take that off and have a look. Right. Socket fits in. screws down. Oh yeah, that looks to be the perfect height. I am now set up to potentially do some fins. I have a 4mm bullnose slot drill, and this is at a 4-degree angle, so as I go across the fins will get shallower, very much like the original Sump. And I'm going to do, I think, 5 slots, and we'll see whether we're actually going to do these edge bits. Not sure that it particularly helps, but it should be okay. Okay, so I've started doing the slot, and I'm just going to basically work back and forth and then stip it over and do the same again, over and over. So I'm doing about a 1/2 millimeter depth cut, because it's a very fine slot drill. But we get longer and longer each time. I reckon to a finish about just where the sump plug actually goes. I have moved the machine 7mm, which will give me a 3mm fin with a 4mm slot. So let's get on with that. So I'm about to do the final cut on, I think, the final slot. I don't think I'm going to do the wings on the side. I think the slots give it enough impression of what the original plate looked like, and I'm not convinced that having the fins actually reduces the oil temperature, because I've got an oil cooler, of course, part of the bike. So I think this is more decorative. Gives an impression of what's going on. So there is the plate sort of finished. I want to take off all the sharp edges, tidy up perhaps around the edge a little bit, and clean up inside here a little bit, and then put it on the flat glass plate, and make sure that this face is completely flat. I could try milling it, but I'm quite happy just with a little bit of wet and dry on a piece of flat glass. So reasonably happy with that, and we shall fit it on the bike and see how it works. Of course, I actually need to buy some gaskets. I've run out.